The spatial intelligence work I've been thinking about in the past few years is truly a continuation of my entire career's focus in computer vision and visual intelligence. Why did I emphasize on spatial is because we've come to a point in our technology that the level of sophistication and profound capabilities of this technology is no longer at the level of staring at an image or even simple understanding simple videos. It is deeply, deeply perceptual, spatial, and also connects to robotics, it connects to embodied AI as well as ambient AI.
Welcome to the podcast. In this episode, I have the honor of talking again to Fei Fei Li, a pioneer in artificial intelligence and computer vision. I had Fei Fei on the podcast a few years ago, and I invite you all to go listen to that episode. I'll put a link at the end of this video. We'll explore her insights on world models and the importance of spatial intelligence, crucial elements for creating AI that truly understands and interacts with the world around us. While large language models are amazing, much, if not most, of human knowledge is not captured in text. And to reach a more general artificial intelligence, models need to experience the world firsthand, or at least through video. We talk about her startup, World Labs, and their first product, Marble, which generates incredible, complex 3D spaces from the model's internal representations of the world. Plus, she tells us her guilty pleasure, watching her favorite TV show on airplanes, and you probably won't be surprised what that show is. Stay tuned for an enlightening conversation.
I'm Fei Fei Li. I'll be joining the podcast of Ion AI and discussing spatial intelligence and world models. Come and join us.
Build the future of multi-agent software with Agency. That's AGNTCY. Now an open source Linux Foundation project, Agency is building the Internet of Agents, a collaborative layer where AI agents can discover, connect, and work across any framework. All the pieces engineers need to deploy multi-agent systems now belong to everyone who builds on Agency, including robust identity and access management that ensures every agent is authenticated and trusted before interacting. Agency also provides open, standardized tools for agent discovery, seamless protocols for agent-to-agent communication, and modular components for scalable workflows. Collaborate with developers from Cisco, Dell Technologies, Google Cloud, Oracle, Red Hat, and more than 75 other supporting companies to build next-generation AI infrastructure together. Agency is dropping code, specs, and services, no strings attached. Visit agency.org to contribute. That's AGNTCY.org. I wanted to talk not so much about Marble, your new model, which is amazing, that generates sort of consistent and persistent 3D worlds that the viewer can move through. I want to talk more about why you're focusing on world models on spatial intelligence, why that is necessary to go beyond learning in language, and how your approach differs from LeCun's. Can you talk first of all about did the world model work emerge from your work on ambient intelligence, or has this been a parallel track?
The spatial intelligence work I've been thinking about in the past few years is truly a continuation of my entire career's focus in computer vision and visual intelligence, right? And why did I emphasis on spatial is because we've come to a point in our technology that the level of sophistication and profound capabilities of this technology is no longer at the level of staring at an image or even simple understanding simple videos. It is deeply, deeply perceptual, spatial, and also connects to robotics, it connects to embodied AI as well as ambient AI. So from this point of view, it's a continuation really of just my entire career in computer vision and AI.
And the importance of spatial intelligence, and I've talked about this, I've had this podcast for a while. Uh, Human knowledge, language models learn from human knowledge encoded in text. But that's a very finite subset of human knowledge. And as you pointed out, many people have pointed out, humans learn a lot from interacting in the world without language. So it's important. We're going to move beyond the current LLMs, as amazing as they are, that we develop models that have more direct experience of the world, learn more directly from the world. Your approach has been, well, certainly with Marble, to take the internal representations of the world that the model learns and create an external visual reality with those. LeCun's approach is to create internal representations from direct experience or video input that allows a model to learn physical laws of motion and things like that. Uh, is there a parallel between that? Are the two approaches complementary or are they overlapping?
So yeah, so first of all, I actually would not pit myself against Young or vice versa because I think we're on the on this continuum of intellectual um just approaches to spatial intelligence and world modeling. So if you probably read my recent long essay that I called Manifesto of Spatial Intelligence, and there I was very clear. I actually think both implicit representation and eventually some level of explicit representation, especially in the output layer, are both probably needed if we are considering a universal omnipotent world model eventually. And they both play roles. For example, our current world model in World Labs, Marble, does explicitly output 3D representation, but within the model, there is actually also implicit uh, representation, um, along with the explicit output. So it is. It is Eventually, I think we need both, to be honest. And also, in terms of the input modality, yes, learning from videos is very important. The whole world is a continuous input of lots of frames. But the whole world to intelligent or just to animals is not just watching passively. It's also, an embodied experience of movements, of interaction, of tactile experience, of sound, of you know, uh, smell and also just forces, physical forces of and temperature and all this, right? So I think it's deeply multimodal, and if you even look at, of course, Marble as a model is just the first step, but in our tech piece that we released just this few days ago, we were pretty clear that we believe in multimodality, um, as a learning paradigm as well as an input paradigm. So, yeah, so I think, you know, there's a lot of intellectual discussions on this. It also shows the excitement in the early days of this model. So I would not say that we have finished exploring exactly the model architecture, the representation, and all that.
In your world model, the inputs are primarily videos, um, and then the model builds an internal representation of the world.
Not quite. In If you experience Marble, our world model, our inputs are generally pretty multimodal. You can do a pure text, you can do one to multiple images, you can do videos, you can also input coarse 3D layouts, like boxes or voxels. So it's multimodal, and I think we're gonna deepen that as we go.
And is the ambition beyond, it's a fantastic product with many applications. Is the ambition to build a system? And when I said the input is video, but to build a system that can learn from direct experience, whether it's through video or some other modality, but it's not learning through a secondary uh, uh, medium like text.
Yes, I think world model is about learning about the world, and the world is very multimodal. And whether it's machines or animals, we are multisensory as well. So the learning is through sensing, and the sensing has different modalities. So text is one form. Again, this is where we depart from animals, because most animals don't learn through sophisticated language, but humans do. But our today's AI's world model will learn from a lot of language input as well as other modality, but it's not squeezed through only language.
Yeah, and one of the limitations of LLMs is that the model parameters are fixed after training. So the models don't learn continuously. There's a certain amount of learning at test time inference. Is that something that you're tackling with world models? Because presumably a world model is learning as it encounters new environments.
Yeah, the continuous learning paradigm is definitely a very, very important one, especially for living beings. That's how we do it. And even there is, online learning versus offline learning. So um in the current form of our world model, we are still more in the batch or offline learning mode. But I'm we're definitely open to, continuous, especially, eventually online learning, modality.
Yeah, and how would that would it I mean, it wouldn't be a very different architecture. It would simply be a matter of engineering, is that right?
Well, I would be open-minded, yeah. Yes, I think it's gonna be a mixture of both, obviously, good engineering, good, fine-tuning online, learning can already happen, but maybe there will be new architecture.
Yeah, yeah. Can you talk about the real-time frame model, which underlies uh, Marble and your work with world models?
Yeah, so you're referring to a tech blog that we also put out a couple of weeks ago that specifically double clicks on our real time frame model. WorldLab is a a a a very research heavy organization. We also care about product, but so much of our work right now in this stage is model first. So we're definitely looking at how uh, we can push forward spatial intelligence, and this particular line of work, which definitely connects to Marble, is really focusing on how we can um, achieve frame based generation with as much geometric consistency and permanency as we can, because some of the early work in frame-based generation, you lose that permanency as you move forward. But in this particular case, we try to really balance and also do it in a compute efficient way during inference, which in this case we achieve through a single H100 in inference time. We don't really know. Some other frame-based models, they don't tell us how many chips they use during their inference time. So we don't we have a hypothesis. It's a quite a number, but we don't know that information to compare ourselves.
Yeah, and in your manifesto, I think you called it, you talk about the need for a universal task function, uh,
A universal what function?
universal task function,
Oh yes, yeah.
analogous to the next token prediction in language models. Uh, does RTFM does have a prediction element to it? What are you talking about when you say universal task function beyond what the predictive element of RTFM?
Well, so one of the biggest breakthrough of Gen AI is really this discovery of the objective function of next token prediction, right? Because it really is such a beautiful formulation because language is in this kind of sequential you can tokenize language in this kind of sequential representation, and your learning function of next token prediction is precisely what you need during inference, which is that as you generate language, whether humans generate or computers generate, it really is putting token after token forward. So having an objective function that is 100% aligned with the actual eventual task that is supposed to achieve or carry out is just is just great because it makes the optimization um, just on target. In computer vision or in world modeling, it is not as it's not as simple because if you look at our relationship with language, it really is just to speak it or to generate it. There's no language in nature that you're staring at it. I mean, eventually you learn to read, but that's because it's already generated. So, but there's, your relationship with the language is deeply generative. It literally is a generated thing by humans, but the relationship with the world is so much more multimodal, I would say, right? There is a world out there for you to observe, for you to interpret, for you to reason with it, for you to eventually interact with it. But there is also a mind's eye that can formulate different versions of reality as well as imagination, and also allow you to also generate the story, the imagined world or so it's much more complex. So what is the task that defines or the objective function that defines a universal function that we can use that is as powerful as next token prediction? It's actually a really profound question because is it, let's say, is it 3D reconstruction? Just some people actually would argue that the universal task for world modeling could be that it's just be able to 3D reconstruct the world because if if that is the objective function, and if we achieve that, a lot of things will fall through, just fall naturally out of it. But that is you could also argue, I don't think so because most animal brain don't necessarily do precise 3D reconstruction, like, it's not clear a tiger or a person actually can reconstruct the world, yet we're such powerful, visual intelligent, spatially intelligent, beings. So maybe that's not necessarily the right task. Then is it the next frame prediction as a way to, as if it's the next token prediction? Well, there's some power to that, right? Like, first of all, there's a lot of training data for this, and second is that in order to predict the next frame, you have to learn the structure of the world, because uh, worlds are not white noise. So there's a lot of structure that connects one frame to the other, and if you do it well, maybe that is the right universal task or objective function. But maybe it is also unsatisfying because you treat the world as 2D, and the world is not 2D. It's so you do you really force the representation, collapse it in a very unsatisfying way. And also, even if you can say if you manage to do it perfectly, 3D is implicit. That's true, but it's also very wasteful because with the 3D structure, there's actually a lot more information that you don't have to lose in a way that frame-based prediction might. So there is a lot of there's still a lot of exploration on that.
RTFM. And I have to ask you, was that a joke, naming it
It
RTFM?
was a it was a brilliant, play with the I did not invent this. One of our researchers is, really brilliant in naming, right? Like, as I don't
Yeah,
know how
yeah,
much we're
yeah, well,
allowed to
I'll go.
say those words here.
I'll say it, yeah, read the fucking manual.
Yeah,
That's
exactly.
the
Ev
acronym, yeah.
every
But
computer scientist knows that, so we find
yeah,
that really fun to just play
yeah,
with that name.
yeah. But RTFM is predicting, the next frame, right?
Yeah,
And,
with
but
3D consistency.
yes, and that's what's interesting about the internal representation that the model learns. I mean, sitting here, I'm looking at my computer screen. I know what the other side of the computer screen looks like, even though I can't see it, and there's an internal representation in my mind of that. And your model does that. I mean, that's why you can move around objects in even though I mean, it's a 3D representation on a 2D screen, but you can move around, see the other side of things. So the model is has an internal representation of the 3D object, even if its current view is can't see the backside of something. And that really interests me. That's essentially what you're talking about when you say spatial intelligence, understanding that 3D world. Uh, is that does that learning include things like the physical laws of nature? I mean, does it understand uh, that you can't walk through a solid object, or that I think on one of the podcasts I saw you on, somebody was talking about using this for people with fear of heights. So you could look over the edge of something, but if you create a, a physical representation, I mean an explicit representation of a cliff, let's say, and you move the uh, the point of view of the agent or the viewer over that cliff, will it know that it's no longer standing on solid ground, or will it float in space?
Yeah, so what you are describing is both physical and semantic, to be honest. Like, of course, falling off a cliff is very much dependent on the law of gravity and all that. And but the fact that you the going through a wall, it's very much material based and semantics based, right? Solid object versus non-solid object. So RTFM as a current model right now is not focusing on the physics yet. Most of the physics, to be honest, coming out of the Gen AI models are statistics. If you look at, for example, a lot of these Gen video models where you do see water running and trees moving, that is not based on a Newtonian law of forces and masses. It's really based on I've seen plenty of movements of water and leaves in this particular way, and I'm just gonna follow that statistical pattern. So we have to be a little careful. Right now, World Labs is still focusing on generating and exploring and static uh, worlds. We are going to explore dynamic, and there, a lot of that will be, statistical learning. Um, I don't think any of today's AI, language AI or pixel AI, has the capability to abstract at a different level and deduce physics, like, at the level of a Newtonian law out of it. Everything we've seen is statistical, based, physical and dynamical learning. We could, on the other hand, put these worlds into physics engines, and these
Yeah, like
engines.
Unreal Engine
Right,
or something. Yeah.
have the laws of physics, and they eventually these physics engines, game engines, and also world generation, eventually they're gonna combine into neural engines. I don't even know, maybe we should call them neurospatial engines or something like that. I think that we are moving towards that direction, but it's still early days, right?
Yeah. Yeah. And I didn't mean to pit you against Jan. What I was driving at is it seems like you're focused on explicit representations coming out of of an abstract internal representation. Jan is just focused on the internal representation and learning, and that's where the learning takes place. And it just seemed to me that they would marry beautifully.
That's a possibility. Like I said, like you already repeated, we are exploring both. The explicit output is actually a very deliberate approach because we want to be useful for people. We want to be useful for people who are creating, who are simulating, who are designing. And if you look at today's industry, whether you're creating VFX effects, or you're creating games, or you're designing interiors, or you're simulating for robots or autonomous vehicles, or industry digital twins, or whatever you're doing, it's very 3D, right? So it's there's entire industry after industry that's very much 3D, in the workflow of 3D, and we want to be absolutely useful for people and businesses to use these models.
And the reason I brought up continuous learning, right now, the model understands, uh, depth of field and other sort of spatial properties. Yeah. Um, what is the learning that is implicit in the model, or that is that the model has, that allows it uh, to generate that explicit representation? I mean, because the ultimate goal is to build a model that presumably can learn uh, over time. I mean, I'm sure everybody, you and everybody else, I mean, I imagine it having a model that maybe it's on in a robot, or maybe it's attached to it's getting data from a video camera that moves around in the world, but that that eventually learns not only the scene that it's seeing, but understands the physicality of the space, and eventually then you marry that with language and you've got a really powerful intelligence. Is that something that you think about? And that would require continual learning, that it's not a finite data set that you're feeding the model, that the model is continuously learning from its interaction in the world.
Yeah, definitely, especially as one comes close to a use case, especially if the use case requires continuous learning. There are many ways of continuous learning, right? Like in language model, we see that taking into context itself is continuous learning, right? Like having the context as memory, so it helps inference. And then, of course, there is other methods of online learning, of fine tuning. So continuous learning is a term that can encompass multiple ways of doing it. And I think in spatial intelligence, especially like you said, some of these use cases, whether it's robots in personal or in customized situations, or artists with particular styles, creators with particular styles, these will all eventually push the technology to be able to be more responsive in whichever time horizon that the use case requires it to be. And some are real time, some are maybe just more you know s- uh, segmented, in the time horizon point of view. So it depends.
Build the future of multi-agent software with agency. That's AGNTCY. Now an open source Linux Foundation project, Agency is building the Internet of Agents, a collaborative layer where AI agents can discover, connect, and work across any framework. All the pieces engineers need to deploy multi-agent systems now belong to everyone who builds on agency, including robust identity and access management that ensures every agent is authenticated and trusted before interacting. Agency also provides open, standardized tools for agent discovery, seamless protocols for agent to agent communication, and modular components for scalable workflows. Collaborate with developers from Cisco, Dell Technologies, Google Cloud, Oracle, Red Hat, and more than 75 other supporting companies to build next generation AI infrastructure together. Agency is dropping code, specs, and services, no strings attached. Visit agency.org to contribute. That's AGNTCY.org. Yeah. And, you've come a tremendous way since you're running a dry cleaning shop, as I recall, in New Jersey, and in a very short period of time. Uh, and you're moving very quickly now. Do you have any sense of where you'll be in 5 years with this technology? Will you uh, have some physics engine built into the model, or will you have the ability to learn in longer time frames and build up richer internal representations that the model can begin to understand the physical world?
Yes, I actually think, you know, it's not, as a scientist, it's very hard for me to give a prediction in terms of precise time, because some part of the technology has moved much faster than I thought, some are much slower than I thought. But I think that is very much a very good goal. And also it's 5 years is kind of a fair guesstimate. I don't know if we'll be faster, but it's a it's a better guesstimate than 50 years in my mind, or 5 months.
Can you talk a little bit about why you think uh, spatial intelligence is the next frontier? Uh, I mean, we've already said that human knowledge is contained in text is only a subset of all human knowledge, and while it's very rich, it you can't expect um, an AI model to understand the world simply through text. Uh, can you talk about why that's important and how Marble and World Labs relates to that larger goal?
Yeah, so I think fundamentally, technology should help people. In the meantime, understanding the science of intelligence itself is the most fascinating, audacious, ambitious scientific quest I can think of myself, and it's a quest of 21st century. Both of these, whether you're fascinated by the curiosity of the science or you're motivated by using technology to help people, it points to one fact is that so much of our intelligence and so much of our intelligence at work goes beyond language, right? It's I kind of lightheartedly say that you cannot use language to put down a fire. And in my manifesto, I described examples, whether it's the spatial reasoning deduction of DNA double helix structure, or a first responder putting down fire in a rapidly evolving situation with a team of coworkers. Um, a lot of this goes beyond language. So it is obvious, both in terms of use case point of view as well as in terms of a scientific quest, that we should try our best to unlock how to develop spatial intelligence technology that takes us to the different to the next level. So that's really the 30,000 feet view that describes how I'm motivated by these dual purpose of scientific discovery, as well as making useful tools for people. And then we can dive uh, and then we can dive deeper into, for example, being useful, like we alluded to a little bit earlier, whether you're talking about creativity or simulation or design or immersive experiences or education or healthcare or manufacturing. There, there's just so much that you could do with spatial intelligence. I'm very excited that so many people who are thinking about education and immersive learning and immersive experiences are telling me that Marble, our first release of the model, is inspiring them to think how to use it for immersive experiences to make learning more interactive and fun. And that's just so natural because pre-verbal children learn entirely through immersive experience. Uh, And and even today as grown-ups, our life, right? Like so much of our life is immersed in this world and involves, of course it involves speaking and writing and reading, but it involves doing and interacting and enjoying and all that. So it's so natural.
Yeah, I mean, one of the things that has struck everybody is that this marble. I'm not sure it's marble or the itself or the RTFM, the generation of next frame um, in a moving through a space, is that it's running on one H100 GPU. Uh, it's and I've heard you in other talks refer to experiencing the multiverse, which everyone was very excited about until they realized how much computation it was going to take and how expensive it is. Do you really think that this is a step toward creating worlds for education, for example? And because you've been able to reduce the computational load?
Not just that. First of all, I really believe at the inference front, we will be speeding up, we will be more efficient, and will be also better, bigger, higher quality, longer, experiences. All this, that is the trend of technology. I really do. Things are moving fast. I also do believe in a multiverse experience. Humanity. As far as we know, the entire history of humanity, our world experience is in one world, and it's literally physically this earth, right? Oh, okay. A handful of human beings have gone onto the moon, but that's about it. Um, and that is the one shared 3D space. And we build civilization, we live our lives, we do everything in it. But with the digital revolution, explosion, we are moving part of our lives in digital world, and there is also a lot of crossover. This is not I don't wanna paint a dystopian picture of we have abandoned our physical world, nor am I gonna paint a utopian total hyperbolic utopian world of everybody wear a headset and never even enjoy and look at our beautiful real world, and that's the fullest of life. I would reject both notions, but both pragmatically speaking, as well as just projecting to the exciting future, the digital world is boundless, it's unlimited, and it gives us so much more dimension and experiences that our physical world will not allow us. For example, we already talked about learning. Just I would love to have learned chemistry in a much more interactive and immersive way, because I remember my college chemistry class has so much to do with arranging molecules, understanding the parities and the asymmetry of the molecular structure. Man, I wish I could just experience that in a experience in an immersive way. I would love for creators to creators I meet these creators, I realize in their mind's eye they simultaneously, every given moment, they have so many ways to tell their story. There's so much in their head, but they're rate limited by tools. If you use Unreal Engine, it's gonna take weeks, hours after hours to express one world in your head. And whether you're making a fantastical musical production or you are, designing the bedroom for your newborn child. So many of these moments, if we allow people to use the digital universe as much as the physical world to experiment, to iterate, to communicate, to create. It's just so much more fun. And also, we also our digital age is also helping us to break the physical boundaries of labor, right? Like I mean, we're looking at um robots that can be teleoperated. I can also totally imagine um creators collaborate across the globe through embodied, robotic arms or whatever form factor, and through the digital space, so that they can both work in the physical world as well as work in the digital world. And movies, right? Movies will completely change. Right now, it's passive experience as much as it's beautiful, but we're gonna change the way we get entertained. So all this require multiverse.
And in teleportation or the teleoperated robots, you could there's a lot of talk of mining rare earths on asteroids and stuff. You don't need to physically be there if you can operate a robot remotely that's in those spaces. What and what you're talking about is again creating uh, explicit representations of 3D space that people can experience. How much in your models does the model itself understand uh, the spaces that it's internalizing before it explicitly uh, projects them? I mean, and that's again one thing that I think about more than the the productization or practical uses of this is working toward an AI that truly understands the world, doesn't just have a representation of 3D space, that really understands not only the laws of physics, but uh, what it's seeing and maybe the values or uh, the usefulness of what it sees and ways that it could manipulate the physical world. And how much of that understanding do you think is there, and what needs to happen for the models to really understand the world?
Yeah, okay. Great question. So, this word understanding is a very profound word. You know, when AI understands something, it just fundamentally is different from how humans understand it. If partially because we're very different beings, right? Humans has a level of consciousness and self-awareness in an um in an embodied body. For example, when we understand something, when we understand my friend is really happy. It's not just a abstract understanding my friend is happy. You actually have chemical reactions in your body that releases happy hormones or whatever chemicals that your heartbeat might increase, your mood might so that level of understanding is very different from an abstract AI agent that has the capability of correctly assign meaning and link meaning to each other. For example, in Marble, our model product, you can actually go to advanced mode of world generation, and in this advanced mode, it allows you to edit. You can take a preview of the world and say, I don't like this couch being pink, change it to blue, and it changes it to blue. Does it understand at the level of blue couch and the word change? It does, because without that understanding, it wouldn't change the couch to the blue couch. Does it understand it that the same way you and I understand it, including everything about this couch, including every useful or not even useful information of the couch? Does it have a memory of the couch? Does it, you know, th- take the concept of couch to affordance, to many other things? No, it doesn't. It as a model, it's limited to allowing you to, you know, do whatever it's necessary the model needs to do, which is to create a space that has the couch that looks blue. So I think so the answer to your question is I do think AI understands, but let's not mistaken that understanding from a anthropomorphic human level understanding.
Yeah, and in fact, whatever understanding there is, uh, when you tell it to swap a red couch for a blue couch, that's semantic. That's uh, semantic understanding. It's not understanding at the level of light and hitting the retina and knowing and having a concept of blueness as opposed to redness. Um, I saw your talk with Peter Diamandis and Eric Schmidt in Saudi Arabia, and and I think you were wonderful in that, much more grounded than some of the questions or even Eric's views. Uh, but one of the things that struck me is there was a brief discussion about the potential for AI to be creative or to help in scientific research, and the analogy that is given, if there had been AI and before some of 'em, like Einstein's relativity theory, or I can't remember the other one that was referenced, uh, could AI reason to that discovery? Uh, what's missing for AI uh, to be creative? I'm not talking about creative in the arts. I'm talking about in scientific reasoning. It seems to me that that should be within reach. I mean, I'm again with no time frame, but that seems just intuitively something that should be possible.
Yeah, that's a great question. I would think we're closer to AI de- deducing double helix structure than AI formulating special relativity. Um, Partially because, I mean, we already have seen a lot of great work in protein folding. Partially because deducing double helix structure is still the representation is is more grounded in space and geometry, whereas the formulation of special relativity is on an abstract layer that is not just expressed in unlimited amount of words. That's just not how it works, right? Everything we see in physics, from Newtonian law to quantum, we abstract it to a causal level that the the relationship of the world, the concept, whether it's mass or it's force, or is abstracted at a level that is just no longer pure statistical pattern generation. Like, language can be very statistical. Um, 3D worlds or 2D world, doesn't matter, can be very statistical. Dynamics can be very statistical, but the causal abstraction of forces and masses and the magnetism and all this are not purely statistical. It is very profoundly causal and abstract. So I I'm more in the pontification mode than answering your question mode. I I think Eric and I on stage were saying, we've got plenty of celestial body data, movement data in the world now. Just aggregate all the satellite data and all that. Give it to today's AI. Can it come up with Newtonian law of motion?
See, yeah, and actually, I found that that was the other example I was trying to think of. Relativity, yeah, there's no physical system that you can observe, at least in day to day life, that would lead to that deduction or inference. But with the data of the movement of celestial objects, I'm not sure. Just again, intuitively, I'm a journalist. Uh, it seems that maybe not today's AI systems, but that an artificial intelligence could deduce the laws of motion if if given the data and uh, and given the time to think, why do you think it would not be able to deduce those laws?
When we say those laws are deduced, Newton had to deduce, has to abstract concepts like forces and mass and acceleration and fundamental constants. Those are at an abstract level that I have not yet to seen today's AI can take that whatever vast amount of data and abstract representation or variables or relationships at that level. It's there isn't much evidence yet. I don't know everything that's going on in AI, so I'm happy to be proven wrong. I just haven't heard any work that has done that level of abstraction and in the architecture of a transformer model. Um, I don't see where that abstraction can come from yet. So that's why I'm questioning that.
Yeah, yeah. It just from my sense, you're building these internal, abstract internal representations, and as that knowledge accrues, I don't see why an AI model wouldn't be able to apply the you know rules
Yeah,
of
no,
logic knowledge.
I'm not saying AI shouldn't or shouldn't try, but it probably takes more progress in our fundamental architecture of our algorithms.
Yeah, yeah, and that was something I wanted to ask. I mean, you use transformers in your in your models. And I've been talking to people about post-transformer architectures. Like, we're certainly not at a breakthrough, but we started talking about uh, this uh, predictive function, uh, universal task function, as you called it. Do you have an expectation that there will be that kind of a breakthrough, a new architecture that will unlock some of these capabilities?
I do. I do. I I do think we will have architectural breakthroughs. I do not think Transformer is the last invention of AI. Um, and in the grand scheme of things, humanity hasn't been around for that long compared to the entire history of the universe we know of. But in this short history of thousands of years, we have never stopped innovating. So I do not think Transformer is the last algorithm architecture of AI.
In one of the conversations, or something you wrote, I saw you were talking about the history of your research, and that at one time you felt if you could get an AI system to label or caption images, you would have that would have been the pinnacle of your career, and of course you've blown past that. What do you imagine as the crowning achievement of your future career today?
I do think unlocking spatial intelligence, creating a model that really connects perception to reasoning, spatial reasoning, seeing to doing, including planning, and imagining to creation, um, would be incredible. A model that can do all three of that.
I have a couple of silly questions I'm going to ask you. What's your favorite food or one of your favorite foods? I'm just curious. I mean, you were born and spent some of your early years in China. Is it Chinese food? Is it uh, you know?
So I'm married to an Italian, and he's a phenomenal cook. in addition of being a phenomenal AI scientist. So I love Italian, and, in our family, uh, when we are being nonpartisan, we love Japanese food.
Not with these days, yeah. That's, yeah. And then, what's your guilty pleasure? Do you read romance novels on the plane or binge watch, uh, you know,
Yeah,
um
that's a great question. First of all, I don't have too much leisure time because what I do is so much fun, but I do have a guilty pleasure. I don't think I've ever told anybody. Um, if I'm really tired in a plane, I watch Big Bang Theory. I love that show, and
Yeah,
I graduated from Caltech. I was a physics major. Everything of that show, I just identify so much with with the people there. It's my I don't binge watch because it depends on the duration of the flight, but that's my totally if I'm totally exhausted, I watch that.
yeah, yeah, and you get the jokes, right? Because
Oh
a lot of
god,
it
I can tell you I love every single jokes and every single character, the nerds in the show.